interviews, Tolwaka. Yes, we know each other from 1996, I think, when I was a postdoctoral researcher in University of Wisconsin-Madison. So I'm originally from Kazakhstan, Almaty. I was born with my parents who are actually native to Almaty region. So both of my parents belong to those Uyghurs that they call Taranji.
Okay. Yeah, me too. I'm Taranji too.
So it's really along the river Ili, as far as I understand. And there was lots of little small towns, of Uyghur towns. That's where my parents actually were born. And the entire my generation to generation of my ancestors actually lived along the river of Ili. And my mom is from Tashtkara. It's about 30 kilometers on the way to Volja from Almaty. So that's actually Uyghur small town where is about, I would say, close to 100% Uyghurs live there for hundreds of years. And I know that my great-grandmother's grandma is in the same cemetery.
Right.
So that's how many years that they've been living. And
how far away is it from the border?
I think it's about 300 kilometers from the border.
300. Okay.
With Vatan, yeah. And then my dad is actually not even 1 kilometer, around 1 kilometer from the border. It's a very close town, Ghaljat, that is very close to Gulja. And that's where my father and all his ancestors. I would say that my dad is really a Guljuluk. So because it's so close to Gulja, and that's where I actually was born, in that small town where my dad is originally from.
You were a Guljuluk too in that case.
I'm a Guljuluk, yes. Okay. So, and that's, and then we all actually lived close to Almaty. And that's the reason I don't write and I don't read Uyghur, and unfortunately, because we didn't have a school where my dad was working at the school as a history teacher. They invited him over there, and my mom was a biology and chemistry teacher. And they didn't have Uyghur language school there. So that's how we actually become Russian speaking. But at home, because in our town where they call it Avat, we have maybe 70% Uyghurs. So still, and especially lots of Uyghurs that came in 1959 to 1962 or 63, whereas there was this massacre, I think, or this is a revolution in Vatan, where, you know, it belongs to China right now. But and lots of Uyghurs flee to Kazakhstan, Uzbekistan, and that's how we have a lot of Uyghurs in my small town next to, very close to Almaty, and they are from all over. They are from Aksu.
Was that? Sorry to interrupt. Was that 1962 or?
Yes, it was about from 1959 to 1963. I think there was a lot of Uyghurs came. Hundreds of thousands of Uyghurs came from Vatan to Kazakhstan. Because
I know those events. But those events.
And that's how, and a lot of Qashqailik, Guljuluk, Urumchidan. There is a lot of Uyghurs came to our small town, and they actually, because we native Uyghurs to that region already, we were there, so they were welcoming, and we become relatives, and that's how I grew up with all these Uyghur cultures. Actually, even we were Russian speaking, because during Second World War II, lots of different nationalities, I would say up to 30 to 50 nationalities, they were brought to Almaty and Tashkent, because those were far away cities still from the war. But all our grandparents, like my both grandparents, went to war. And one, my grandfather, whose last name my last name become his first name, become my last name, Mitalip. He actually died defending Moscow in 1942. It was November 4, 1942, whose graveyard I just found last year. After 76 years after he died, I finally found his graveyard. And that's my dad. And another, my grandfather, his name is Asim. And Asim Qasimov, he died defending Stalingrad during Second World War II. This is my mom's father. So we all Uyghurs are local Uyghurs in Almaty region. There is no family who didn't lose somebody during Second World War II.
Okay, yeah. Yeah, I mean, actually you speak Uyghur language pretty well, you know, because today our audience are basically, you know, English-speaking people, so, you know, we'll probably chat a little bit in Uyghur too later on. But let's get on to the point, you know. So you are a scientist. So what have you accomplished in terms of academic research, and what inspired you to you know, study biomedical science? So
yeah.
One of the questions that I'm interested in.
Yeah, so when I was young, I think I always wanted to be a doctor, but somehow I didn't become a doctor, but I become a biologist. But I think right now I like my profession better because I'm actually a scientist and I'm in biomedical research, which is related to medicine very much. So when I was young, so I went to Moscow actually right after my brother. My brother, Shuhrat, went to Moscow. He was already in a college there. So
he's a very famous guy.
Yes. He talked me into this, and why don't you come over and study in Moscow? So when I graduated high school, I left to Moscow, and I was actually doing a bachelor, master's, and PhD together with my older brother. So we spent 13 years studying in Moscow together. So we actually pretty much studied for the same. We did a PhD also in the same lab. So we went to college to do the same, and the same department actually. And we actually had a bachelor and master's in agricultural university. They call it Timiryazev University in Moscow. We did, both of us did in genetics and embryology at the agricultural university. And this was animal genetics, not the human, because it's agricultural. And that's how we might be very much related to animal science and cloning, both of us. My brother did it in primates and I did it in bovine. So, and then we went to for PhD together into the same lab, and that was actually already a medical genetic institute in Moscow. So we were, with my brother, we were first in Russia who actually did a mouse stem cell research using mouse embryonic stem cells. We did engineer them, and we used those cells as a model for human diseases. And that was, for both of us, that was our topic of our research for in our graduate school in Moscow. So then my brother went to Germany in '95, and I was still 1 year behind him, and I got my PhD in '96, and I received my PhD, and I went straight to United States, where my brother did 1 year postdoctoral studies, research in Germany. And then from that point, we actually split, and he was at Utah State University from 1995, and I was at the University of Madison, Wisconsin, where I think it was pretty lucky for me, because one of the really famous embryologists, mammalian embryologist, invited me, and he's actually a godfather of all cloning, because he actually is the one who trained all these scientists who cloned the dolly, and from his lab all these famous scientists actually came out. and I was one of his last maybe postdoctoral researchers.
Mm-hmm.
So I would think that Neil First, that's his name, a professor who actually within like about 5 years I worked with him, and he really made me as a scientist, and I owe him a lot because I learned so much from him. And that's when I did a mouse embryonic stem cell research in Moscow, but when I came to Wisconsin, I did it everything on bovine, with the cows. So, and when I came, I was supposed to isolate stem cells from cow embryos, from bovine embryos, and that was my project, to use them for bovine cloning, actually. But then Dolly came, as you mentioned, and then my professor Neil First said, you know, we should actually try to clone calves from skin cells. So you take the skin and you actually clone. And but stem cells was something that I never wanted to give up. So I did it. It became my weekend project. And during the 5 days during the week, I was trying to clone the bovine, and that's how we actually. It's not because I was the famous, of course not, but it's because my professor was so famous when the dolly came, and he was interviewed by all these media and the press and the newspapers. And since I was the only one in his lab who was doing a cloning, he would actually refer them to me, and that's how we actually came up in the first page of New York Times when Dolly came, and then we were interviewed by New York Times. And yes,
I didn't catch it. You said you were the only one
in his lab, yeah, who was doing cloning. Yeah, you know, there's lots of projects in the lab, and he was giving me a project that I had to clone the cows using skin cells of the cows. But at the same time, I was doing research using isolating stem cells from bovine stem cells. And
I remember when I visited Indiana University, you were there, right?
Yes, I was there.
You were so busy, but I know that the talent
yes, and I go, yes.
He invited us. Then he mentioned that you were so busy, but you did spend some. He did. At that time, you explained what you were doing, and that's a continuation of the study that you've been doing, right?
Yes, and then and actually the whole process of making how the dolly came, why this dolly become such a unique, I would say, technology. It's more like a technology. So until dolly came, and I think scientists could not reprogram completely differentiated. We call, for example, if the skin cells, they have a program when they can be only as skin cells. So if you look at the skin cells, all the genes in the cell on the skin cell are all turned off, except those genes that actually make the protein that have to have a function for skin. For example, defending, protecting. So the body. So this is what is actually differentiation process is. For example, neuronal cells become a post-mitotic, and they only have genes that are actually expressed, only genes that are necessary to make some proteins that will have a function for the neurons. And that's how, the whole body is function, and doesn't matter if it's an animal or the human or anybody. So, and what was remarkable about the dolly, that it's actually a skin cell that is completely differentiated. We call it somatic cell, and actually can be turned back. Like if the dolly was, let's say, like 3 or 5 years old animal, so the skin cell of the dolly, or mammary gland cells, that's what she was actually cloned for. So we'll be back to 2 years or 5 years as much as she lived. And that's what the stage you return that the genome, the nucleus of that of that cell, and actually it becomes again will have a ability to differentiate to any other cell type. So that's you bring to the, this is the oocyte. You need to use the egg, so which is an oocyte, and then what you do, you actually remove the genetic material from the egg, and you actually put there into the cytoplasm of that egg, you put a nucleus of the completely differentiated cells. And of course, this procedure is not that easy, but you have to activate, and so you fuse that, and that DNA, or let's say nucleus, completely gets reprogrammed by the cytoplasm of that egg, and then from completely differentiated, let's say skin cell, you can actually make entire animal. And that was such a remarkable, and this is in 2012, there was two scientists who got a Nobel Prize, and one of them, Shinya Yamanaka from Japan.
Okay.
And I think it's a John Jordan from UK. And those two, and John Jordan is actually known that he is the first scientist who actually cloned the animal, but that's not a mammalian animal, not mammals, but it was cloned amphibian, so that was a frog. It might be, so it was about 50 something years ago when he cloned, and that's for his achievement, he got a Nobel Prize. And the second person who actually did this in 2006, and then in 2009, there was another remarkable revolutionary technology was developed in biomedical science, and that we call it reprogramming. So what it is, reprogramming, and again, when you take a patient or patient's skin cells or any other cells, differentiated, and not using the egg, but by using chemicals or small molecules, you can actually turn off or turn on the genes. And in this case, this technology allowed to turn on the genes of embryo, that stage of pre-implantation stage, and make the stem cells from that skin cells. Literally, you take a skin cells and then you bring them back. Let's say patient with Parkinson's disease, a 70 years old patient, and then I take the skin cells of that patient, like my mom, for example, and then I can culture her cells in Petri dish, and then by using, right now we're using non-integrating mRNAs, and that's how we actually trigger that we actually literally wake up those genes that are actually turned off during the embryogenesis, and when the cells become, gastrulation and all of the type of the cells, and that's how we need to bring it back. And why do we need it? We need the stem cells, skin cells, to turn to stem cells in order then directly differentiate those cells into the cellular type where the disease actually target that patient. In case of the Parkinson, it will be neurons and brain cells. In case of the heart diseases, and there are some lots of heart diseases, those will be cardiomyocytes. In case of something else, so we can actually turn the stem cells of those patients that we actually reprogram. And this is what in 2012, another scientist together with John Jordan got the Nobel Prize, and his name is Shinya Yamanaka. And my lab here at the Whitehead Institute, of course, we've been very close to that as well, but Professor Yamanaka, of course, deserved that Nobel Prize.
Okay, I hope you will be the next.
I think this
is that one of your goal to? Is that one of your goal in your scientific career to get this academic?
So I started. So I probably will been known in my field of stem cells for one of the first person who isolated human stem cells in the world.
Okay.
So, and some of my very first human stem cell lines, when there was not many, it's only been like 10 in the maximum that time, and it was 2001 when around 4 of those, nearly half of those available cell lines in the world, I isolated myself when I left the University of Georgia and joined I went to Georgia, state of Georgia, in the United States, and in Atlanta I was able to isolate human stem cells there. And so the company that I worked for, this was a biotech company named Brasagen. It's an Australian company, and the goal of the company was to study Parkinson's disease, and they call it cell therapy program for treatment of Parkinson's disease. And this was about 7 years before my mom was diagnosed with Parkinson's disease. It's quite ironic.
Sorry to hear that. Yeah, sorry.
Yeah, it was quite ironic, but so we worked very hard to study Parkinson's disease using human embryonic stem cells.
Mm-hmm.
And working there for about 2 or 3 years, I realized that these complex diseases are very difficult to study in a company, for example, like a biotech company, because biotech company is mostly they need to make drugs, so they have to bring something to the market.
Yes.
But in order to study those kind of diseases like Alzheimer's disease or Parkinson or many diseases, so I realized that you need to go back to academia. Yes, we have to write the grants and we have to propose what we want to study, but this is very expensive research in order to do it in the company. And company was great for me to start, because in academia at that time I couldn't isolate human stem cells. Mm-hmm. But when I isolated, and it's good that company actually allowed me to publish, and then I published 2 papers in the company, and then by 2004 I was looking for a job, and that's how I came to Boston, like nearly 14 and a half years ago.
So I just wanted to jump on, ask one question. I know a lot of scientists who conduct basic research, right? They really don't like work in the company because, like you said, right, company is more like profit driven, even, do drug research, or even in our field, right? I work for the companies, of course. Most of the time, you have to consider the profit that you can bring to the company. So you cannot really delve into the, basic research. So
companies
is that the kind of feeling that you had, and you?
I think for that particular moment, I realized that to understand the mechanism of the diseases, it was impossible to do in the company, because companies just wouldn't have that much of freedom.
Yes.
To ask the questions that is necessary to understand the diseases like Parkinson or Alzheimer's. But the companies are great in many ways, and I think they contributed tremendously to a lot of research, and they do a lot of great research, like the companies here, Novartis, Merck, and all of these companies right here next to me in Kendall Square. There's more than 20 really pharmaceutical and biotech companies, and I think they're great places. And
you do a lot of cooperation with them, right?
Yes, we do. Yes, definitely. We collaborate with the companies. But at that time, when I was doing the research, I think what my interest was, and I really had to go to academia, and I still think that I was lucky enough to come to Whitehead Institute, MIT, where I think I really enjoy working, and especially a professor that I work with, Rudolf Janisch. He's a very famous scientist and professor in the field of stem cells, cancer, and epigenetics. And it was very mutual because Rudolf Janisch needed somebody with my experience, and I really needed somebody with his knowledge and experience. It was such a mutual interest, and the Whitehead Institute is a great place. And it's been, what, 14, over a little bit over 14 years, and we still do our research, and I still enjoy.
Yes, that's the best part, right? Enjoy what you are doing. Yeah, so I want jump onto something else, right? I know that
yes,
very informative information that you explained related to the biomedical research and such. So let's come back to the politics a little bit, right? Yes. Recently, I know that you involved in this what is called the China Tribunal.
Yes.
And the China Tribunal had worked very hard, and they revealed the tragedy, from China related to the live human organ harvesting. Mm-hmm. You are involved in those great project, because that's one of the things that I think scientists has to involve in order to, to make those. They make those kind of, evil doing, right, revealed to the world. Yeah. So could you explain to me what the China Tribunal is? Because I have a lot of...
Yes, so about forced organ harvesting, of course, we heard before China Tribunal, and I think for many years, there was, for over 20 years, we knew that the forced organ harvesting was conducted in China and in mainland of China. And that time, the major target was this group of people they called Falun Gong practitioners. And just because there was such a humane practice, and it's like a Christianity and some form of religious practice, with the based on humanity and love and nature. And for some reason, this group in China was growing to hundreds of millions and hundreds of millions of people start following such a peaceful religion as a Falun Gong. And when this happened, even in 1990s, Chinese government saw it as a threat for their communist regime, I think, totalitarian regime. And I think that's when people, human rights, a journalist, Ethan Gutmann, and he has published at least 2 or 3 books. And then there was a human rights lawyer as a David Mathis, who actually spent years researching in China and looking at them. At this forced organ harvesting, because these people were prosecuted by Chinese government, been placed in jail, and in 1990s they started actually killing these people in prison for their organs and selling. And from that time, when officially China would say that they have about 10,000 organ transplant a year, they would actually reach over 60,000. And now we even hear the numbers like 100,000.
That's a year, right? 1 year?
Per year, yes, that's what it is. It's one of the countries that the most supply organs for organ transplantation. And of course, I didn't know anything of this until just recently, I would say in November or so last year, when the Uyghur scientists, I would say scholars, intellectuals in the United States contacted me, and they said, my son, we heard that from 2016, entire population of East Turkestan, and specifically Turkic, meaning Uyghur, Kazakh, and other Turkic people, not Han Chinese, they were subject to a health check but a mandatory health check. But not only health check, they were the blood was withdrawn, and the DNA for DNA sequencing, DNA testing. And they asked me, can you please, as a medical researcher, as a biologist, maybe you can actually find out what do they use this for. And this was, I would say, around fall of 2018, last year. And then I started actually going deep into this. Why? So we know what is a DNA sequencing. For example, you take a DNA, you isolate DNA from the blood or from any from any tissue. So then you actually can sequence the DNA. It's like really a letters, you know, and then this and letters would have a specific sequence. For example, the words would be those. There is a nucleotide. There is only 4 of them, and and those 4 nucleotides would actually make a letter, and then the numbers could be changing, and that's how we read, actually translate into the protein, and that's what the DNA is. So when you do this sequencing, you actually try to read it, how each protein has a sequence of amino acids, which consist of this, and the position of each nucleotide is very important in order to have a proper sequence and proper protein. And there could be a slight differences, and those we call it mutations. And those mutations can cause a disease. And there are some that very slight, like 1 nucleotide, and we call it 1 nucleotide, small single nucleotide polymorphism, which doesn't cause any disease. But every one of us, for example, if I am related to my mom, we might have a lot of this single nucleotide polymorphism, which is very similar, and I inherited from my mom. So that's how, and I myself as a human being would have those SNPs. We call them SNP, which stands for single nucleotide polymorphism. So I was looking what for the DNA sequencing is used for. So we know that DNA sequencing is used for in medicine. So we would actually sequence the DNA of, and then we look at the genes, and we would look at the genes that actually, if there is a mutations in terms of the disease, and which actually mutation may cause diseases like Parkinson or Alzheimer's or any other diseases. So, and we know that we have to find those. That's how we do actually a sequence, and especially we look at the genes that are specifically expressed in the brain cells. And that's what you need it for. The second would be necessary for, let's say, if you want to look at your ancestries, you know, this is also, you can use it, and you can trace your ancestors by DNA sequencing. And then that is called DNA fingerprinting. And then another thing that you would, for anthropology, for example, you use it in anthropological studies, you would use a DNA sequencing in order to, again, you know, and then another few actually purposes for DNA sequencing, and another one is for forensic. In the scene of the crime, for example, you would have, you know, there is a small even hair left by the person who committed the crime or the victim, and then you can actually find those by DNA sequencing. And this is pretty much what you need to use it for.
Yeah.
But then I was thinking, why would they use 20, let's say 15 to 20 million people DNA and sequence? This is not very cheap. So I actually went to some of my colleagues. I don't do per se a DNA sequencing, and I'm not an expert on that, but I went to a person who actually does it for her career for 30 years or so, and I actually literally interviewed her. I said, could you tell me what this can be used in such a large scale. And we were discussing for almost an hour in her office. And then we came to the same conclusion, both of us. And yes, this probably the only way that they used it in order to match a recipient who actually need an organ with the donor. And I tell you how this whole can be used. For example, there is a compatibility. There is an immune system. For example, if I'm not compatible with somebody's, so I cannot receive his let's say, even blood transplantation for example, bone marrow for leukemia. So in order to receive the bone marrow transplant in case of blood cancer, in case of leukemia, you really need to have a pretty good match between the donor.
In this case, it has to be exact match, right?
The match doesn't have to be exact, but it has to be very well matched. So then there's, especially in blood transplant, meaning bone marrow transplantation, if there is no very close match, so then it will be rejected and the person will die after bone marrow transplantation. And a lot of cancer patients go through this. The same for organs. Maybe it's a less than for bone marrow transplantation, but it's still the organs. For example, there is a statistic: 60% of the organs after transplantation, after organ transplantation, 60% have a higher risk of getting rejected by the next 2 years. And this is statistic for today. I looked at the literature of organ transplantation, and this is mostly due to very low matching between the recipient and the donor. And that's the reason why these organs, up to 60%, get rejected after in next 2 years after transplantation. That's number one.
Yeah.
And if you have it matched better, then you need to do a DNA sequencing. And there is now technologies. These technologies were not available 10 years. There are some technologies were not even available as now, today, even 5 years from now.
Yeah.
So right now, the technology of DNA sequencing come to such a progress, then we can actually match recipient and donor. So if an average donor organ stays in recipient who actually received that kidney, let's say, and there are some that are actually better, they have a better chance of staying in a patient, in a recipient than others, and those are kidneys and livers are better than heart and the lungs. So they have a heart and lungs have much higher chances of getting rejected. So, and if I looked at the scientific literature in a medical transplantation, organ transplantation. For example, in kidney transplantation, they have seen when they had a chance to better match a donor and the recipient by DNA actually sequencing. So the percentage of the rejection was minimum.
Mm-hmm.
It would go from, let's say, the 60%, it goes way lower than 10%. So the next 2 years. And if it's the average organ stays with the patient after transplantation, lives with the patient 10, 15 years, that's the guarantee. If you have a DNA sequenced and matched the donor and the recipient, that organ will stay up to 30 years and plus.
Mm-hmm.
And the price for the organs, there are some prices out there, and I looked it up. And there is nothing less than 100,000 literally per organ. So China is known that they do a forced organ harvesting for more than 20 years. And in 2015, Chinese government or their medical association proved to the world, because this was investigated for many years, and they proved that they stopped because they actually admitted that they had
yes, I read about that. Yes.
organ harvesting, done this procedure from prisoners of conscience, meaning those that political prisoners.
But later they said they stopped it, right?
Yes, but we know that they didn't. And this was in 2018, the trials, they call it China Tribunal, who actually had conducted independent research. And this was from the Coalition of Against Forced Organ Harvesting, and they call it ITAC. This is the non-profit, non-government organization that is based in Australia, who actually literally ask to build a China Tribunal, or to launch such a tribunal, an independent investigation, and they were the one who actually helped. And what is a China Tribunal? It's a China Tribunal is actually 7 judges, and who actually had hold the trial and hearings, and there was 2 hearings. One was in November 2018, where they had lots of witnesses who actually testified in front of those 7 judges. And then there was another, and then there was another hearing in April 5 to 7 of this year, 2019, where they had another hearing. There was 2 hearings for China Tribunal, and then after second hearing, where I actually testified, but I didn't testify as a witness, or that I know that somebody in my eyes, or I have seen anybody who actually gone through this forced organ harvesting. But because in March of 2019, there was Dolkun Issa came to Harvard with a talk, and I met with him, and I actually told him about this, my findings, what I actually learned. And he said that to me, you know, my son, there is this China Tribunal in London. Do you know about this? I had no idea.
Oh, okay.
Said, can I get you in touch with this Australian coalition against forced organ harvesting, and maybe you can actually talk to them, and maybe you can testify, because what you're actually saying about a link between DNA sequencing and organ transplantation is very important for this China Tribunal to hear.
Okay.
So, and this was actually end of March, so we only had 5 days. So, so he actually connected me with Susan Hughes, who is the head of this organization. And Susan asked me to write an article and submit to China Tribunal. I had only 2 days to write it. So I put it about 3 pages, an article, a link between DNA sequencing and organ transplantation. And I sent that article to China Tribunal into London. And then they told me that they want me to testify in front of this tribunal, and this was the last day of hearing, and I was actually at the meeting in Japan at that time. So they asked me to testify on the 7th, and it was 3 o'clock in the morning, and so I testified. So they asked me for good half an hour, they asked me all the questions about the DNA sequencing and how I can prove it. And my only proof was, so because this was done in a large scale, and this was very expensive. And imagine right now, if you do a whole genome DNA sequence from one patient, one DNA. So still, depending on the depth of DNA sequencing, you at least need $1,000 per one sample, per person. Okay. So then the least expensive DNA sequencing machine, and we know that there was in March of 2019, New York Times had an article that Thermo Fisher company here in Waltham, where I live in Massachusetts, actually sold to Xinjiang at least several of those $500,000 machines.
Okay.
DNA sequencing machines.
Okay.
So when I looked it up, and because next door to me to MIT, there is a Human Genome Institute where they do those large-scale DNA sequencing. And the machines that are least expensive machine is about $500,000, between 300,000 and $500,000. So in order to service these machines, you need a very well-trained technicians. In order to do a DNA isolation, you really need minimum master's degree scientist. In order to read, after you actually do sequence in those machines, you literally need a PhD level biostatisticians. And if you multiply this into 20 plus million samples, so everything, if you account everything, machine cost, this is not a single private entity would do this for fun.
Okay.
This is never will be done for the police. Imagine you will do, because Chinese government actually said that, oh, we're gonna use it for forensic. We will do it entire billion of people of China. There is no way that anybody can afford just to find, let's say, even 100 of criminals. You cannot do a DNA sequencing of entire population because this is very expensive.
Yes.
And the reason you would do this, if you would have a very well-paid back outcome.
Yeah, benefit, right? Benefit.
And the benefit of accounting, if they spend $500 million, we're talking about billions of dollars back. Because the organ that actually they can promise by DNA sequencing will match the recipient and will stay with that recipient much, much longer than any other organs, then those organs, even in black market, they will cost maybe a triple price rather than any. And I tell you why we cannot do this matching a recipient in. This is what was asked by China Tribunal judge, Jeffrey Nice. He asked me, Dr. Mitalipova, why do you think that DNA sequencing cannot be used, for example, in West? That was one of the questions that I was asked. And I tell you why. Because imagine, when do we actually volunteer to give our organs? Only after our sudden death. Right. And that's why when we actually get a driver license, we put ourselves as a voluntarily, remember, voluntarily, we sign up as organ donors during our sudden death, which can very much happen while we're driving and in case of accident. What happens? So you have a window of couple of hours when there is an entire United States, there are patients are waiting for different organs.
Right.
And those patients are actually on the call list. And then there is some organs donated. and there is a list, waiting list, and then this patient will be notified, and then will get into the hospital, and then the donor of the organ who voluntarily signed in an accident died, and then there's the helicopters could take it immediately, that body, and bring it to the hospital, and the organs will be removed, the organ that is necessary for. And this is, we're talking about the hours, not days. For the DNA sequencing, you need quite a bit of time of the patient that is waiting for. That can be done easily. For example, even that patient who needs the organs has so much time in advance that he can actually give a blood and his DNA sequence, and it's waiting in the computer. But that recipient who actually died today and can be actually your organ donor, that person who died and donor and voluntarily during his sudden death gives that donor, that particular donor's DNA needs a time to sequence. And where is the chance that this patient who is actually waiting can be a perfect match with the person who died? The chances are very little. And no one in advance, even if I am a donor and sign up as a donor, even if I go, so somebody has to pay for it, for my sequencing, DNA sequencing. Even if it will be staying in a database, there is very hard chances that I will die at the time when my perfect match will need my organs, That's why in the West, this is hard to do. But in China, especially, if you look at East Turkestan, right now from 2016, they are in the camps. And there is a need. There is this patients that are they have submitted their DNA already, and they say, oh, I need the such and such an organ. And then there is a database where the millions of people are waiting, and all you have to do, just blast it, the DNA sequence of the recipient, and all these donors, 20 million of my beloved Uyghurs, Kazakhs, and so on. And when there is a perfect match, it all gets done by 1 hour or so in the computer system. And then that one patient will be, oh, this is a much better perfect match. And that person, if he's not in the camp, in the prison, he might be just walking on the street. And maybe he will have no choice to Loka, but he will have every social score or no reason that that person will get into the camp. And then he will be disappeared in that black hole of those camps.
Yeah, one of the things I noticed that in all those camp those people in camp, right? They were very, very healthy. One thing that I was wondering is no donor would like a sick person's or weak person's organ. Right? That was probably
and I testified in front of China Tribunal for those things to explain to judges during my testimony. And I think at the beginning they were probably, because I didn't have any evidences, hardcore evidences that this is done. But I think as a scientist, I proved my point.
Yeah.
And I could see it after half an hour of my testimony in China Tribunal. I could see how judges actually already were talking to me and asking me questions. And I knew it. I already got their respect.
Yes.
They actually asked me, some questions, and I told them that, yes, I'm a scientist. Yes, I'm an Uyghur. Yes, I'm here to testify. I'm not testifying only for my fellow Uyghurs, because none of the human being should be subject to forced organ harvesting. And this is a crime against of humanity. And this needs to be stopped. And I really appreciate that that such a thing was happening as a China Tribunal, and that I could actually take a place in such a, you know, my knowledge, maybe my curiosity per se, or yes, as a biologist and as a, you know, and this is, I really wanted to participate, and I was really hoping that they will choose me, because I had such a short time to put up that article. They will choose me as a testifier, and they did, and I'm happy that I was able to testify and answer them every question they had, and to prove that my point, why they would do such a thing, what for. You know, it's very expensive procedure. And in the 17th of June, they had a verdict that this is happening. It's true. There was enough witnesses that testified in front of.
It's in the UN what, Human Rights Council, right?
Yes, he's the counsel of China Tribunal, but he actually gave a talk last week at the UN in Geneva, and they had at least two or so witnesses who actually served a time in prison. There was Omar Bikhali and another person who actually came from the camp, and they specifically in their testimony said that how they were, you know, when they were tortured, they were specifically tortured, not their organs. They wouldn't beat their organs, but they would do their hands, their feet, a head, but not the organs. And they actually, there was even one person actually heard that the guards, Chinese guards, would say, oh, you know, don't hit the organs. You know, the organs, we cannot hit the organs, because these people are being used for their organs.
That's just
this was very
horror movie, right?
Testimony in UN last week.
So my son, I know that China Tribunal is not really a real court, right? They cannot, or can they? I mean, can they order, you know, to arrest somebody and do that kind of thing? I mean, if it's if they can't do that, I mean, what would be the of this?
So, yes, there is impossible to stop this country. If it would be possible to lock up, we would have forced somehow to close the camps and release our people, and all of this could have been done if this is possible. And the same thing was forced organ harvesting. And what we did, it's not even because of the China Tribunal, but because I participated in China Tribunal, I happened to get to know these people who were working tirelessly for years against forced organ harvesting. And those organizations as a Doctors Against Forced Organ Harvesting in DC, and there is a MD, PhD, the doctor, American doctor, who actually found that a non-profit organization, they call it, his name is Thorsten Trey. And then there's this Australian organization that calls Coalition Against Forced Organ Harvesting. And that is based in Australia, but it is a world organization. And this has just happened to be that I got to know these people through China Tribunal, because I was one of the witnesses to, as an expert biologist, I was testifying in front of China Tribunal. So in May of 2019, I went to Uyghur between Uyghur scientists, and this is Erkan Siddiq Aka, Mehmet Emin, Arishat Aka Abbas, and myself, we went to Toronto for the meeting in front of a pretty good group of Uyghur people in Toronto. And one time when I actually, when I go right now, I talk about forced organ harvesting and the link between the DNA sequencing of Uyghur and other Turkic people and organ transplantation. So I actually was asked, and not only myself, but all of us been asked on Sunday when we were leaving, we were asked to give a talk in one of the big mosques in Toronto, in front of medical doctors. Those have been Muslim medical doctors. But what they did, we actually did it in front of maybe not many, maybe like, let's say 50 people or so, but they made a video of our presentation there and actually showed to a couple of hundred medical doctors of Canada. And my presentation, and the professor of Medical University of Toronto, her name is Aliya Khan. So Dr. Aliya Khan contacted me by email in mid of May and told me, Maya, the doctors were so outraged in Canada. They want to do something. So why don't we unite and do something about this? And then we talk like on Skype like this. We spoke with Dr. Aliya Khan, myself, and we decided that we will actually build a coalition against forced organ harvesting. And I asked Aliya Khan, I said, why don't I bring already existing groups like American a group of against forced organ harvesting, this that foundation, and then Australian, and that's how we actually united 4 countries. It's a US, Canada, and Australia and UK, and now we have about maybe 20 something people of us. So we decided that we will. So what we did, because this is impossible to stop China, what we can do, so we actually are trying to get the letters electronically on Google Docs to regular citizens and the medical professionals, like medical doctors and scientists, to sign the letters. And for each country, we make a draft of 2 letters. One is a letter for a citizen of Canada, for example, and then the second will be a medical doctors of Canada. And that's how you sign it up, those letters electronically. And then by doing this, we made 4 countries, 8 letters. And in 2 months, we got over 600 doctors in the United States actually signed it.
Signed up, yeah.
Yes, more than 500 citizens signed it. And same thing in Canada, and then also in UK and Australia. And right now we have a Canadian Medical Association already aware of this. We went with this list of these signatures, went to these associations to condemn this practice and stop there. So the whole purpose is to stop a Canadian to go for organs to China, to stop American citizens to go for organs to China, and Australian and UK. So right now, there is 6 countries that actually already banned their citizens to go to China for organs.
Okay. Which 6 countries?
This is Israel, as far as I know, Taiwan, Belgium.
Yes. US, no?
No, not US.
Okay.
Some other countries, I hadn't known it. There's 6 countries only.
Okay.
Yeah. We need more. So we need, because we have almost 300,000 Americans. We have maybe less Canadians. So we need entire West countries. And you know, Antulaka, this is not that you can stop people to go. They can actually get this $200,000-300,000 and go. But if there is a legislation in a country like United States, even if the American citizen will go for the organs to China and get it,
Right.
or let's say from Falun Gong,
Yeah. Yeah.
or from Uyghur, then he comes back. What this legislation does, they cannot have a post-operative insurance, medical insurance.
Yeah, one thing I'm thinking of now, right? You know, just as we speak, right? So, I mean, if we can, right, submit some kind of proposal to the U.S. government, and that
I already did it. So on the
you did
6th,
that already. Okay. So, what's the chance that? I mean, this is a good case, right? That should be much.
Especially after China Tribunal, after all of these documents that we have in hand.
Right.
So by end of July, I
Right.
went to meet with. I had an appointment with Congressman Jim McGovern,
Mm-hmm.
and I brought all these signatures, even though
Yes.
it's electronic, but
Okay.
I printed out, and I
Mm-hmm.
brought all of this, and the verdict of China Tribunal I brought to his office, and I spoke about this. How can we put, and he was right. In 2014, in Congress, there was already a bill against forced organ harvesting, to stop Americans to go to China. This was already proposed in 2014,
Okay.
but only 6 senators signed this proposal. There was not much of the support from the government.
It's not getting any popularity among Congress.
So what I talked to Jim McGovern and I asked if we can get an amendment to Uyghur Human Rights Policy Act as one amendment to stop American citizens to go to China for
organ harvesting.
Not as a separate bill, but as an amendment. Right. So it was actually received very, very well because Congressman McGovern, he's actually head of subcommittee in Congress, and that's the International Affairs Subcommittee. So he told me that not every bill that you can actually do amendment. So right now I'm waiting for Congressman to actually speak to some of the people, key people in Congress, that we actually bring this issue. So he told me that I should actually come and testify in front of Congress and give this talk about the DNA sequencing.
Okay, sure.
And we will actually postpone this for this fall, and I hope that I will write again to Congressman McGovern. I keep in touch with him, and he gave me an email address of his assistant, Gladys. So I'm actually in touch with them, and I'm trying to get this going. And I'm not alone, as you know. I'm working with this group of really good people. It's human rights lawyers and human rights activists, scientists, medical professionals, professors of medical universities. We get together every 2 weeks and in the morning. So then we do discuss this and we try to come up. So we already have about 10 countries we actually wrote letters. Now we're doing it for Germany, France, and Netherlands.
So you think the let me see, the recipient, right? Recipient, has to be reached based on what you described.
I don't know
usually
how.
Come from recipient should be concentrated in wealthy countries, right? Western wealthy countries.
Most likely, but there is such a term right now we heard as a halal organs.
Right.
And this is like done by Saudi Arabia. And I heard that there is a direct flight from Saudi Arabia to Xinjiang.
To Urumqi, right.
And they call it medical tourism. there is even term as a medical tourism. So, and you imagine who is a donor for halal organs? Of course, our Uyghurs and our Kazakhs and so.
Is this I just want to ask you last question. I know it's very late.
Yes.
You're tired. So is this widespread phenomenon happened in China or just in East Turkestan? Or I know you mentioned.
I think it's a wide phenomenon in entire China.
Really, or Chinese are.
Yes, Chinese citizens are subject to this.
Chinese citizens. Okay.
Yes, yeah.
Other than Falun Gong.
I think other than Falun Gong as well. And lots of Falun Gongs right now, either they are abroad and non-Falun Gongs are anymore left in China. Literally, these practitioners are literally either they killed, imprisoned, or they are abroad.
Yeah, I mean, sort of. I heard these things right when I was in East Turkestan. Like back 30 years ago. Later, 10 years, 20 years ago, I also heard about prisoners.
So this practice was
going on. But I didn't know, right? Today, when I heard this 100,000 people a year, that's
100,000 a year.
To I sort of link this to the concentration camps where 2 to 3 million Uyghurs are in there. I mean, they're can be called some kind of a organ bank, right? That's what
they become.
They're doing it in a commercial style, pretty much.
Especially, the fact that they are building crematoriums next to the camps, and we know this fact, and this is very important fact for us to prove that this is actually happens, because you know that in our culture we don't cremate the bodies, non-Uyghurs or Kazakhs.
Right.
We only have a burial tradition. Right. And why would you actually cremate and not give it away to bodies to the family? And this is one of the evidences, and then the fact that they actually build more hospital infrastructure in Urumqi and in Kashgar, and then also they have a in airports they have a special lane that you can actually pass without waiting, and they actually even ride it on the lane, the green lane that for organ, passing with the organs. There is a pictures already in some of the articles how Chinese doctors in their scraps actually are carrying the organs in those.
I mean, this essentially a genocide.
It is genocide.
Genocide crime, and how come? I mean, that's another bigger question. How come the United Nations can't do anything about this?
Yes, and that's why I think in the United Nations in Geneva last week, China Tribunal had a really big session, and they had brought witnesses from the camps and the prison, and they really wanted this to be heard by United Nations. And as you know, how many, literally there is not a single newspaper that didn't publish it last week. Not only when the China Tribunal had a verdict, but also. So right now we're also trying to work with lots of medical journals to not to publish papers from Chinese researchers, medical research that's been done, because it's been done without any informed consent. And if there is a informed consent that they actually submit when they actually write the article, submitting the articles, those consents that should not be trusted, because they were signed under pressure, if the people are in prison. So those things that we're working on, and if there will be a less people that can go to China for the organs, there will be a less that's how we can decrease, you know, this forced
Killings. Yeah.
killings. Yes, and I don't see any other ways to stop it. But we have to do something internationally. We have to get attention of people, just regular citizens. We have to get attention of medical professionals. And then we have to get attention of the government. But we can only do it with the help of citizens.
Yes.
If
Yes.
citizens will condemn this practice and will sign thousands, hundreds of thousands of these letters, then the government has no choice but take some action, because their own citizens are condemning this practice, and this is a crime against humanity, and this is
Absolutely. Yes.
and I want to contribute to this as much as I can.
Yeah, you've done a lot, and I just recently realized that, like as you said, right? Most ordinary citizens probably, didn't aware, such horrible things are happening. As I just heard, 100,000. I was thinking of probably a few thousand or few hundred, like that. But
No, this is
100,000
and we
is
know
very
that
horrible.
Chinese citizens
Right.
actually, at least one that are actually have voluntarily
Right.
donating their organs voluntarily, and the society, Chinese society, is a very even they have a 1.5 billion of people, but society is very not willing to voluntarily donate the organs after.
Yeah, tell you what I can do. I can definitely sign one of those letters, and I can probably get some people.
I did
Yeah.
yeah, I did Facebook. We did as much as we could. Because it's electronic form and you just click it. It just, it takes a few seconds, not even a minute to sign.
Yes. Yeah, I'll do that. I know I'll check your link, and I'll do that, and probably get more people sign those letters. Just as a citizen, right? So I know that I take up too much of your time, but just want to see you have a last few words to tell our young folks, right? Especially there are a lot of folks, young folks, who wants to be like you, right? Like work in the scientific area, but they're confused, right? Especially in this commercial area, people pay less attention to, the basic research. They pretty much jump. Lately, probably heard about a lot of people go to IT, right? They finish high school, then, train for a few months, and then get good job and paid a lot of money. Then they stop, stop. They lost interest in doing, studying hard. Study is hard, right? You have to go through. So what's the advice you would tell those young folks if somebody,
I always think that not everybody would become a scientist, and not everybody would like to be a scientist. I would just say that just follow your dreams. You want to have a profession that you actually will like.
Right.
You would like to do. And when I ask myself many times, would I be a different profession or something, I always think that how lucky I am at what I do, because there's things that you really like to do, and I hardly could actually sit even on a weekend. I do go back to the lab, and this research become part of my life. And
that's what you love to do, right? Yeah.
Yes, and especially another thing I want to tell Uyghurs, not only young but also maybe adult Uyghurs, we are losing a lot at the moment. As an Uyghur, we are probably the hardest time in our history. There was a lot, always was a struggle, even from my grandparents I heard. And Uyghurs have always been in a struggle in the history. And that's why we might be so resilient. That's why Uyghurs like to study. And they also take very seriously whom they want to become. And I know lots of our Uyghurs are like that. And so I really want to say that I want you guys to preserve your language, to preserve your culture as much as you can. Please teach your children to learn your language, meaning Uyghur. Tell your children as much as you can about our culture. Tell the history of our people. Make sure that your kids would love, they would listen instead of listening at the night some stories. Tell them the stories of Uyghurs. Yes, I know that maybe it is a struggle, but you can come up with a lot of good stories to your kids. But from very young age, I want you to put into your children the love for Uyghur culture, Uyghur literature, Uyghur language. We have to preserve it, because when we are far away from our homeland, it's very hard to do. And I can understand parents that they get really tired. They have a job and everything, but please do it, because your kids will appreciate when they will be grown up, that you actually force them to learn your Uyghur. And also, I want to tell to adults, I know that not many of you come up openly and do something for Vatan, for people who are right now in prison, in the camps, and who are not in prison and camps, they are in open air prison. And I am, as an Uyghur, I get very emotional.
Yeah, I know everybody. Yeah, we have the same feeling. Yeah, it's so hard.
And I want to tell you guys that you cannot just be quiet. You have to testify. If you lost your relatives, not all, but even few, even one, your neighbor, your teacher, your brother, your cousin, your father, your mom, you should not be afraid of testify. Just go out, testify for those, because those people who are right now in the camps, and some of them got 20 years in prison for nothing, just for being Uyghur, for being professor, for being scientist, for being a singer, for being a musician, for being a businessman, for praying to Allah, for his dua, for having Quran at home. For all of these, right now they are struggling, and they're giving unfairly. They're giving a sentence for tens of years. I just imagine people, my people, I want you to come up. I want you to say something. If we all come up, the world will know how many millions are in the camps, how many are missing. Each life that is missing in those camps and in prison, it has a whole story, a life story.
Yes.
So it's a family tragedies. And I understand that it's easy for me to say because I'm from Kazakhstan. And I don't, when I come up and protest, I know that my relatives back at home not in danger. I completely understand this, that I am in different position that you guys are. But we need you to come up, to testify, to protest. because world needs to see us together. I by myself standing in Harvard Square or in Boston Common, I can tell, but I only have a one voice. But if I would have hundreds of voices, it will be so much more powerful. This will be not one Sam Maya alone, but this will be hundreds of thousands of people on the street testifying, protesting, just telling that this has happened and we have to stop it. And I promise you, if we all do this like Hong Kong people do, then we can get some changes. It will happen, these changes. It may not happen tomorrow, but I know that I will stand there. I promise, even in the winter, I will stand there and I'll protest because I want this to be end. And I understand why. And I don't judge you. Don't get me wrong. I don't judge you. Why are you so afraid of getting your loved ones to be in trouble? And I still want you to come up. I still want you to unite. It doesn't matter what group you belong to. And I'm so proud of you guys that you are tirelessly working. And I'm not alone, I know it. And we all have to unite and we have to do something. And there is a long way ahead for us to get our land free of this oppressor. And thank you.
Oh, thank you very much. Very emotional. Yeah. So I hope of course you are continuing your demonstration. I heard that you're going to be continue until the end of the year. Here in DC, we are also doing the demonstration, as you can see. But one day I'll go to Boston and stand beside you to do the.
Thank you so much.
Independence of the East Turkestan is all our dream.
Yes. I have never been in Vatan, and this is my dream. And I know that one day I will go there. When it's
we will, we all will. This because this justice is still will prevail in this world. Thank you very much, my son, taking your time.
And sorry that I spoke all in English. Rahmat.
Rahmat sizga bek avar oldunuz endi. Yana davomlashtiramiz keyin Uyg'urcha so'zlaymiz, yana bir vaqt. Bo'ldi, rahmat. Abdan shukrim.
Rahmat.
Dadingizga urug' tuqqanlar salom aytib qo'ying.
Aytib qo'yma, rahmat.
Xo'sh.
Rahmat.